For today's presentation on controlling runoff, I need you to listen and learn something. You don't have to take any notes. I don't want you to write anything down. Matter of fact, at the end of this presentation, I'm going to give you a summary note sheet, and you have to fill it out completely enough to prove to me that you watched this presentation and that you learned something. So first big idea that's driving this discussion today is that we know that when precipitation hits man-made stuff, those impervious surfaces like roads and buildings and parking lots and such, almost all of it will become runoff.
So think about it when it rains here on our campus. We've got this big building and this big parking lot, which is nothing but a bunch of impervious surfaces. So all of the water that hits the school and the parking lot and the roads becomes runoff. And the question becomes, where does all that runoff go? So there's the school and there's the parking lot, and you can see we're going downhill this way. So all of the water that can't get into the ground and becomes runoff is going to want to move downhill. And over here is the low point. So all the water is going to wind up in this low point. It's not going to go up that hill over there. It's going to come down here and sit. And we're going to have too much water on the road. We're going to have a flood. And we don't want our road going through the low point to be covered with water, because then we can't drive on it. Down here we've got a natural water course. We've got a little stream where the water over time naturally wants to go into, but we have created too much runoff. By having a big parking lot and a big school, we have created too much water that this stream cannot handle, and it would cause a flood. So we can't let all of our runoff from our campus go into this little stream, because it would be too much for that stream to handle. So what do we do with it?
So let's look at what happens when too much runoff does collect in a low-lying area. So all that extra runoff from all those man-made surfaces has to be managed. And the question is, how do we do it?
So my rain hits the roads, the parking lots, the building, it starts to run downhill, and I don't want it going into that stream beside our campus. So where do I put it? Well, the first step is I run it into that right there. That's a storm drain. This is a man-made transport of runoff water, and that is connected to a pipe. And that pipe's going to take all of that runoff somewhere where it's not going to cause me problems, where it's not going to flood my neighborhood or my roads. The question is, where does that pipe go?
So where does all of that water in a storm drain end up going? Remember, water can't be created or destroyed. It's here. And if we make the extra runoff, we got to put it somewhere. Well, some of it can go straight back into the natural water cycle. Like we can put it right back into a river, because remember, it's precipitation. It's clean water. So we don't have to do anything with it. Let's just run it back to where the water would have wanted to go to begin with. However, when we run it into a storm drain, we got to be careful about what goes in the storm drain, because some of these storm drains are going to move straight to our water courses. So whatever we put in the storm drain winds up going into the river. And there's obviously stuff that we don't want to get carried to the river. So you'll see these signs and these little stickers on the storm drains to remind us that, hey, this water is going to the river. Let's keep it clean. We definitely don't want to do something like this. And this is why you should be careful about the chemicals and oils and such that wind up on our streets, because when it rains, then the runoff water can transport that to our rivers through these storm drains. We also want to be careful with clogging our storm drains. Even though things like leaves and dirt and such are natural, they're not necessarily bad for the environment, they will clog up our storm drains, which means our storm drains can't move the water that we want them to move, which means we don't move that water out of the way, and it causes those problems that we saw before. This is down in Macon, Georgia. The Water Authority was having such a problem with people blowing their leaves or their grass clippings into the street that it was clogging the storm drains. They can now actually write tickets for people that are putting this stuff in the street, which then clogs the storm drains, which inhibits the ability to transport and move around this runoff water. When storm drains get clogged, there are many cases where roads end up becoming impassable because you have to wait for the water to drain off. This is on 285 and I-85 over in Gwinnett County, and it is notorious for clogging up. When it gets clogged up, the Department of Transportation will have to send some guys out there in a truck and some rakes and some shovels that to find the storm drain under the water, and then they have to scrape away all of the trash that's on top of it, which is keeping the water from draining.
So let's talk about the difference between storm drains and sewers. We know that that is a storm drain, and it is meant to catch runoff water. All the precipitation hits these impervious surfaces, slides off the roads, slides off the roofs, and we collect it into that pipe and we take that runoff water somewhere. If you were to get into the pipe and you wiggled your way backwards, you would not wind up inside of somebody's house, because that's not where we're getting precipitation collected from. So a storm drain collects only runoff water from precipitation. This, however, is very clearly labeled sewer, and you notice it's out in the middle of the street and there is no opening to it. We don't want runoff water to go into here. We want runoff water to be in a storm drain. So what's in there? Well, if you were to go down and wiggle your way back through the pipe, you will wind up in somebody's house. You'll wind up in their toilet, in their sink, or their shower, because that water is not clean. It's dirty water, it's poopy water, and it has to be handled differently than the runoff water running alongside the road, which is clean from precipitation.
So what happens to the water in a sewer? Well, the water is not the same, so it's got to be handled differently. Storm drain versus a sewer. Well, storm drain water, because it is clean precipitation, can be put right back into the natural water cycle because it's not dirty. However, sewer water, which is dirty, we don't want getting into our rivers. So a sewer transports the water to a water treatment plant, which cleans the water before it goes back into the natural water cycle.
Now this access, on the other hand, says sewer. If I were to crawl down in that pipe, those pipes are connected to people's houses and they transport dirty, poopy water to water treatment plants. Now it's rained real heavy and you can see the storm drain is certainly overflowing, because the storm drain is handling runoff water and that water is clean. So even though we don't really want it to wind up in the river and cause some flooding, it's okay because it's clean water. This should show you how this is different. This pipe isn't overflowing because it's not connected to the storm drains. This is not meant to handle runoff water. So that's why we don't see any water coming out of this, but we do see water coming out of the storm drain.
Here in Atlanta, the water system in the city of Atlanta is old and it needs to be updated. And every time they have a spill where they get sewage that winds up being dumped into the natural water cycle, they get fined. You can see recently there was a settlement of $700,000 that the city of Atlanta had to pay to the Environmental Protection Agency as a fine because they let poopy water get into the natural water cycle. Now, yeah, we can send that clean water to rivers and streams, but rivers and streams can only hold or transport a certain amount of water. So we cannot let all of the runoff that we have made from all of our impervious surfaces go to the rivers. It's going to cause flooding. And that's what a flood is. A flood is when surface water escapes its normal boundaries. So over here we've got the natural water course where water wants to move. And we want water in our rivers. However, if we allow too much water to go to a river or a stream or a water course, it's going to fill up and it's going to come out here. That's what a flood is. A flood is when water gets out of its normal path. So what can we do with all that runoff water if we just can't send it directly to the rivers and streams because it would cause flooding? The answer, in the simplest case, is retention ponds.
So here we've got a big building and a parking lot with lots of impervious surfaces, which means every time it rains, every drop of water that hits this area is going to become runoff, which we then have to manage. Let's look at what we can do with all that extra runoff that is created. So we collect all that excess runoff water and we run it in. So what you see back here behind me is called Martin's Lake, which is the big lake in the middle of the Martin's Landing subdivision right close to the school. And this is a really big neighborhood with lots of houses and lots of roads and lots of other buildings. And when they built this and they put in all these houses, they created a lot of extra runoff. And as we've talked about before, you've got to have a plan to manage that extra runoff. And here's what they did. They ran it all into this area here. So basically, this Martin's Lake is just a really big, fancy retention pond. As a matter of fact, most of the ponds and lakes that we have in our local neighborhoods are nothing more than fancy retention ponds. Because before this neighborhood was built, this was all woods and trees and plants, and the water would have infiltrated the ground. Well, once they built the houses and the streets and the roads and the parking lots, all of that extra runoff was going to end up going that way, which is where the Chattahoochee River is. Now you can imagine if all of this extra water wound up in the river, we would have a lot of really serious flooding problems. So once again, retention ponds are built to hold excess runoff water.
Most of our lakes in our area are not natural. They are actually retention ponds that are holding excess runoff water from all these roads and buildings and houses and such that we have built. This means any developed area with man-made impervious surfaces needs something to help manage that extra runoff.
So here's the retention pond on Innovations campus. And you notice it doesn't look like a pond and have any water in it because retention ponds don't necessarily always have water in them. What's happening here is the storm drains on our campus collect all that excess runoff from all those impervious surfaces and it runs it over here. And the water sits here and it does one of two things. It either infiltrates the ground or it evaporates up into the air. Either way, this retention pond holds excess runoff that our stream over there couldn't handle, and therefore we have less flooding.
Now, a drainage ditch is an alternative to a storm drain.
So take a look at this situation in Florida where it does rain a lot. We got some houses, got some roads. All that precipitation is really going to become runoff, which means it has to be managed. Normally we would put that into a storm drain, but look at the situation here. What we've got is just a big ditch right beside of the road. This is called a drainage ditch. You can see it's very simple. The water runs off the road, winds up in the ditch, and then it goes somewhere. Now this is in Florida where the ground is not very steep, so the water has a tendency just to kind of hang out in these ditches. So where does it go? Well, if you'll remember, the ground in Florida is very sandy, so the water is able to infiltrate into the ground. It does its job. It gets our rain from our impervious surfaces someplace where it can then be managed. These aren't as good a solution for managing runoff in Georgia because our ground is clay. And if water got in there, it would just kind of sit for a long time. And our ground is too steep. The water would run through these ditches and eat it away and take it away. But in Florida, where the ground is flat, the water will just sit here and hang out until it can either evaporate or infiltrate.
Here we get drainage ditches, very commonly used in Florida as opposed to storm drains. Here is one in use. This was a nice summer thunderstorm. You see the drainage ditch filled up with water, and I came out about 8 hours later, and this is what it looked like. The water was gone because the water infiltrated the ground or it had evaporated into the air. It just sat in that ditch until it did one of those two things. It's a pretty good option. Keeps the water off the street and keeps us from having flooding. We have some drainage ditches in our area, especially the more undeveloped it is, the more rural it is. So what happens, water will come off the road and kind of hangs out there in these ditches. It'll then slide down to a river or a stream someplace close by. Now, drainage ditches work great in Florida, but they don't work as well here in our area. Here's why. Florida's flat, so when the water falls, it sits on top of the surface, and because it's sandy, the water is able to infiltrate. In Georgia, we've got clay, so the water, even if it's sitting in a drainage ditch, it's just going to sit there too long. In addition, we have hills. So in Georgia, the water is going to try to run downhill. It's not just going to sit there in a ditch and hang out until it infiltrates. And it would take too long to infiltrate anyway because the ground is clay. So we've got some advantages and we've got some distinct disadvantages of retention ponds. The first, they're big. You got to set aside a really big area to hold all of that water. I want you to think about a neighborhood like this over here. Somebody bought this land and they built houses. The more houses they build, the more money they make. Well, there was a big chunk of land where they were not able to build houses. They had to set aside that land for a retention pond. So they take up a lot of space that you could use for something else. Here's a new retention pond built at a fairly small development in Roswell. And you can see it's pretty good size. And that's land that you can't use for anything else except to hold some water. Second disadvantage to retention ponds is they can be kind of ugly and dirty. Because remember, you got trash, you got leaves, stuff kind of goes down in the storm drains, and it winds up in this retention pond. So they fill up with dirt and trash. They can be smelly, they can be scummy. They don't look pretty. So generally, we don't want to have these someplace where we're looking at them. In a neighborhood, they might be put in the back of the neighborhood. Shopping centers are going to be put someplace behind a row of trees where you can't see them or you can't smell them. Third disadvantage is that they have to be cleaned out because they are naturally going to fill up with stuff, leaves and dirt and soil. Well, if the pond fills up too much with dirt, it can't hold enough water. And the whole reason it's there is to have space for all of the extra water that we want to be held onto so it doesn't go somewhere else and cause flooding. Now, there are some alternatives to retention ponds. Bioswales is the first one we're going to look at.
So here we've got a big shopping center, which is a big building, big parking lot, and every drop of rain that's going to fall on that building or this parking lot is going to become runoff because it cannot get through this surface into the ground. Remember that buildings and parking lots are what we call impervious surfaces that water can't get through to get into the ground. Well, all of this extra runoff has to go somewhere and it has to be managed. Well, most of that runoff we're going to run into something like this called a storm drain, and we're going to run it through a pipe and we're going to take that storm water somewhere and have to hold on to it so that it doesn't get into the river and cause flooding. Usually that's a retention pond. The problem with this is I got to build a pipe from here and I got to allow some land for a retention pond. I got to hold on to that water for a long time. Well, this Target shopping center is trying something new and different, a little bit better alternative to building storm drains. So what they've done is build what's called a bioswale. A bioswale is a low-lying area that's filled with plants that allows for the absorption and infiltration of precipitation. Now the water still hits this parking lot, but it runs off, and instead of going into a storm drain, You see it's allowed to go through this opening here, and it goes into this low-lying area. And you see we've got some trees and we've got some plants here. And two things happen to this water. It either goes into the ground as infiltration, which is what it would have done before we built the parking lot, or these plants are going to help soak up the water through their leaves from the soil, and the water is then going to go back up into the sky via evaporation. So once again, this is called a bioswale. A bioswale is a low-lying area filled with plants that helps in managing excess runoff.
Here at Centennial, they built this new building, and that was a more impervious surfaces. They had to go to the city of Roswell for a building permit and say, hey, we want to build this new building. And Roswell said, well, wait, you're going to have more runoff. What are you going to do to manage that runoff? And here's what they did. They took a section of the parking lot and they built a bioswale. You can see it's a little low-lying area. The water is going to come into here, and it's just going to hang out in that area, and the trees are going to help drink it up. And it limits the amount, or reduces the amount of water that's then going to run off into the storm drain and make its way to the Chattahoochee. Here's what it looks like after it rains. You can see it's doing its job. It's holding on to a lot of that excess water. Here's some other examples of bioswales. You can see how they work. Water has a way to come in from off of these impervious surfaces, and we've got a bunch of plants there that are just going to love to drink up that water and spit it back to control excess runoff and prevent flooding. But let's think about this. What if we could keep extra runoff from happening? Then we wouldn't even have to do all those things. We wouldn't need as much storm drains. We wouldn't need as big of retention ponds. If we can do something to let the water get in the ground like it wanted to do in the first place. Well, we can't make less rain, but what if we can make less water run off? Let's look at some options that we can actually make less runoff even though we have a lot of rain. The first example is going to be porous or permeable pavement.
Okay, so here we've got a CVS, a building, and we've got a big parking lot, which are nothing more than impervious surfaces. And every time rain comes down out of the sky, it hits these surfaces and it has to go somewhere because it can't get into the ground. Most cases, it goes into that storm drain and we have to take it somewhere and hold on to it so it doesn't cause flooding in the river. Well, now this CVS did something a little bit different with their parking lot to help manage the excess runoff caused by the building in the parking lot. And they built this right here. They made part of their parking lot what's called a permeable parking lot. Permeable, remember, it means that it allows water to go into the ground. And you can see this, that it's got the ground in between these pavers. So when it rains over here, the water can get back into the ground and infiltrate instead of becoming runoff. So this is another way that we can help manage excess runoff. It's by making what we call porous or permeable pavement, which allows water to infiltrate the ground and lessens the amount of runoff that we have to manage. So let's look at a way that we can actually make there be less runoff. We can't make it rain any less, so the rain's going to hit the ground. And we've got parking lots, we've got buildings, we've got roads, we've got to have those things. But let's see, how can we do something different that makes it where those surfaces don't cause as much runoff? Here's a good option. This here is called a porous or a permeable paver. It is a block material that you could lay down and you could pave a parking lot, especially with this. And you can see it has a lot of open spaces in it. So when the water hits it, the water can go in the open spaces and kind of hang out in there. It is also permeable because it has these open spaces. The water will go in very easily and it will also come out very easily, as I can demonstrate for you right here. You can see as fast as I pour the water into it, it goes straight through it. So now, instead of water moving across the surface, the water is going to go into the ground like it would have naturally. So this is a good option as a way to actually make less precipitation become runoff. It will be allowed to infiltrate.
This was at a Wendy's I was at in Covington, Georgia, and I noticed that they had some of their parking spaces that were made out of this porous concrete. The main part of the parking lot is still asphalt, where you got to drive, gets a lot of use, but the parking spaces were made out of the porous concrete. And I decided, let's conduct a little science experiment. I took 2 cups of water, same amount of water, poured one on the porous pavement. You'll notice it seems to be hanging out right here because it's going into the ground. And on the asphalt, it's becoming runoff. So this porous pavement allows that water to get into the ground and lessens the amount of runoff. Now, we can't use porous pavement everywhere. We can't build a road out of porous pavement. It's just not strong enough. It would not support the weight of a big truck, and it wouldn't even support the heavy use from a bunch of fast-moving cars moving over it. So we're limited where we can use this porous pavement to allow for some more infiltration. But let's look at some great locations where we can use this porous pavement and help increase infiltration.
So this would be a great example of a place where porous pavement would actually work out well. Because if you think about a mall or a shopping center parking lot, for a good portion of the year, nobody parks out here in these spaces, except maybe at Christmas time. Well, that means the rest of the year, you could have this, instead of being asphalt, you could have it be that porous pavement, which would reduce the amount of runoff that you would then have to manage. A great example of where this porous pavement would work would be a church. Because if you think about it, the parking lot's pretty much only used one day a week. And there's no big heavy truck traffic, people aren't driving fast. So if you had the parking lot of the church made out of porous pavement, it would reduce the amount of runoff that you would have to then manage. So here's an appropriate location where that porous pavement is being used. I'm at Riverside Park here in Roswell, and you notice behind me, this is a natural surface, and you see inside that grid, it's just rock and sand. So when it rains, the water is able to go into the ground. Now the main part of the park over there is still paved because that's the area that gets a lot of traffic, gets a lot of use, so you make that out of regular pavement. But this big parking lot over here that isn't used very much is a very appropriate location to use this porous pavement that's going to allow more water to go into the ground.
So an example like this is an event center in Florida where it doesn't get used very often. It's like a concert venue. Well, most of the year it's just sitting there with no cars on it. So why pave it at all? And this works very well in Florida because as it rains on this nice flat sandy soil, the water is just going to infiltrate. Whereas had this been a paved parking lot, it would have all become runoff. It can even be something like this. This is over at UGA in Athens, where they're doing some studies on situations like this that can help increase the amount of infiltration. This part of the parking lot is just made out of gravel, which the water is going to move through. Here's some other situation where houses made their driveways out of a material that is porous. In some places where they have such serious concerns about managing runoff and increasing groundwater, homeowners can actually be incentivized. They can be given a bonus when the house was built to put in porous pavement to help allow more water to go into the ground. Here's a couple other examples. You can see it's got little holes in there where the water is able to go into the ground. This here is a walkway, and you can see it is primarily natural rock. It's got a little webbing that helps hold it in place, but that allows water to go into the ground. Now our roofs, we want all of the water that hit our roofs to go in runoff. We don't want any of it going into our house, which means it all becomes runoff. And then we typically run it off the house, and it runs to the driveway, comes out of our downspout, and we send it to the street, and we send it straight to those storm drains. Think of how many houses are on your street. Everybody's doing this. That's a lot of water that we got to move via the storm drains. In some places, there are some better options. If we took that downspout And instead of sending the water out to the street, if we buried it in the ground, we can get that water into the ground because that's where some of it would have gone anyway. Now, this doesn't work very well in Georgia because we have too much clay and the water would not come down and into the ground fast enough. But in a place like Florida or a place where the ground is fairly dry most times, like a desert environment, and especially if the soil is sandy, this works great, and then you don't even have to have a storm drain. You can just send the water directly into the ground. Rain barrels are another option. This is a case where we collect or we catch that water coming off the roof of the house and we don't let it go to the street in the storm drains. The added advantage of this is you can then use that water for stuff. You can't drink it because it came off your roof. You don't know what's been up there, but you can use it to water your plants, water your lawn. In some places where they have real serious water issues, houses will come with a tank under the ground where they will catch all of that runoff water and then you can use it. In some cases, you can even use it to flush a toilet. Now, once again, you can't drink it. You're not going to shower with it, but it's a way that you can reduce the amount of runoff, and in a place that maybe it doesn't rain very much, you're holding on to water that you can then put to good use. Green roofs. We talked about these with temperatures. They also help with runoff because every drop of water that hits these roofs is going to be drank up by the plants and put back in the air, which means less runoff that has to be managed. So at this time, you come see me for your summary questions and prove to me that you learned something from this presentation.